Okay, so we're going to be talking about the Calculus BC 2009 FRQ question number 4. And the first thing to notice is that it is a non-calculator question. And it reads, consider the differential equation dy over dx equals 6x squared minus x squared y. Let y equals f of x be a particular solution to this differential equation with the initial condition f of negative 1 equals 2. And part A states that you need to use Euler's method with two steps of equal size starting at x equals negative 1 to approximate f of 0 and show the work that leads to your answer. So our first step, we know that the point negative 1, 2, there's a point negative 1, 2, and we're going to use point slope form to get that first equation using Euler's method. So plugging in negative 1 and 2, we know that dy over dx when x equals negative 1 is going to be 6 times 1 minus 1 times 2, so 6 minus 2 is 4. Oops. And then you have your first equation, y minus 2 equals 4 times x plus 1. And then we want to use two steps of equal size, so we're going to use a half. So at negative 1/2, we're going to plug in negative 0.5 into this equation to get that point, which is going to be 4 times 0.5, which is 2, plus 2, which equals 4. And then we can write our next equation once we know what when x equals negative 0.5. We want to find the slope. So we're going to plug in negative 0.5 comma 4 into dy over dx, and you get 6 times 0.25 minus 0.25 times 4, which is going to be 5. And then we're going to plug it into the form. 1 minus 4 equals 0.5 times x plus 0.5. And then from there, we're going to plug in 0, because that's what we want to estimate, and we get 4.25. And that is our estimate. Now the next part of the problem, part B, involves a Taylor series. So that's the great part about this question number 4, is it's combining all different kinds of concepts. And it says at the point negative 1 comma 2, the value of d squared y over dx squared is negative 12. Find the second degree Taylor polynomial for f about x equals negative 1. So first, we know this point, and we know that this d squared y over dx squared equals 12. Negative 12, actually. And we know that dy over dx at the point x equals negative 1, of course, is going to be 4, because we already discovered that in part A. And so to write the Taylor poly, we're going to start with f of negative 1, which is 2. And it's times x minus 1 to the 0 power, so we know x plus 1, my bad, to the 0 power, so that's just 1. And then plus f of negative 1, which is 4, times x minus negative 1 plus 1 to the first power, all over 1 factorial. And then we're going to go to the next degree, which is going to be minus 12, because we know that f double prime of negative 1 is that x plus 1 squared all over 2 factorial. And that's going to give us 2 plus 4 times x plus 1 to the first power minus 6 times x plus 1 squared. And that's our second degree Taylor polynomial. Now the final part, part C, the hardest part, states to find the particular solution y equals f of x to the given differential equation with the initial condition f of negative 1 equals 2. So we know we're going to have to use an integration technique to solve for y. So our first step is going to be to factor out the x squared. X squared 6 minus y, so that we can separate the variables. We want to divide by 6 minus y, so that the y's and dy's on the same side, and then x squared dx. And then we can integrate both sides, so we get a negative ln of the absolute value of 6 minus y plus c1 equals x cubed over 3 plus c2, because those two constants are going to be different. And then if we subtract, we can get one common c value plus c. And now we want to use our initial condition to find the value of c. So we can plug in negative 1 and 2, negative ln of 4 equals negative 1/3 plus c. So we get c equals 1/3 minus ln 4. So now we have our equation and we have a c value, so we can put these all together. Negative ln of 6 minus y equals x cubed over 3 plus 1/3 minus ln 4. And we want to get the y by itself, so we're going to reciprocate, we're going to multiply the negative by both sides, and we're going to raise this to the e power, e to all of this, so we can get rid of the ln, and we're going to get the absolute value of 6 minus y equals 4e to the negative 1/3 times x cubed plus 1. We can drop the absolute value bars because the negative is going to equal positive, so we can get y equals 6 minus 4e to the negative 1/3 times x cubed plus 1, and that's going to be our particular solution. Now some topics of focus and topics that we covered in this question are Euler's method, Taylor series, and integration with an initial condition. And some other problems that you can use that would be very similar to this problem are 2010 number 5, 2008 number 6, parts B and C, and 2012 number 5, part C. Some other tips you want to keep in mind when approaching questions like this one is being careful with steps in Euler's method, because you do not have a calculator and you have to be careful when you have to use 2 different steps or possibly 3, and there are a lot of mathematical errors that can be made or errors in point slope form. And you also want to be careful when you are doing integration with an initial condition, because you have to remember plus c and you do not want to solve for c at the wrong time.